Okay, so question 11. Looking at a situation where we have a wheel that starts from rest at t equals 0 and undergoes a constant angular acceleration. And then when t equals 2 seconds, the angular velocity of the wheel is 5 radians per second. So we can use this information to solve for the angular acceleration. And the acceleration continues until t equals to 20 seconds, when the acceleration stops. How many revolutions does the wheel rotate through in the interval from t equals 0 to t equals 40? So we're looking for the amount of revolutions, so that will be linked to the change in the angular position, and then so looking for delta theta. So in this situation we can think of delta theta is equal to omega initial delta t plus 1/2 alpha t squared, for a case of which where there is an angular acceleration, or we think of delta, so this is when alpha is not equal to 0, and then delta theta equals omega delta t when alpha is equal to 0. So the top one's when we have an angular acceleration, and the bottom is just when we have constant angular speed. So in this particular case we're going to have both of these involved in this problem, in that for the first 20 seconds there is an angular acceleration, but for the latter 20 seconds there's just constant speed. So we will need the alpha. So we know that at 2 seconds, during it when it has a constant angular acceleration, we know at 2 seconds its speed is increased from rest to 5 radians per second. So our alpha is equal to delta omega over delta t. This is a change of 5 radians per second in a time period of 2 seconds. So our alpha for that initial 20 seconds is 2.5 radians per second squared. Okay, so then what I would do for this question is divide the delta theta as 1 into a phase where you have constant angular acceleration, and then another phase where you have constant angular speed. So let's switch the colors here. So our delta theta total will be equal to delta theta from 0 to 20 plus delta theta from 20 to 40. Now we know the initial angular speed is 0. We know the 20, we know the alpha, but I don't know what yet at this point what the angular speed is at 20 seconds. So before we get to complete this, or maybe if I write this in just to show you why we need that information. So this will be omega I delta t plus 1/2 alpha delta t squared plus some omega times delta t. So these delta t's I have, both of them happen just to be 20 because of it's 0 to 20 and 20 to 40, but be careful here that these actually represent, they could represent in a different problem at different times. If it was like the first 25 then 25 to 40, that these delta t's would not be the same. But sorry, this is from 0 to 20, and this is 0 to 20. We're sort of breaking this up into, this is delta theta 1 plus delta theta 2. So we know the omega initial, we know the alpha, we know these time intervals, but I don't know what this omega is at this point, so I need to first solve for that. So the omega, at for the 20 to 40 seconds will be given by the final speed at the end of this acceleration phase. So we know that it's accelerating at 2.5 radians per second squared for 20 seconds. So my omega final here is just going to be equal to my alpha times delta t. Because again, I know what the initial is. The initial is 0. So we have a 2.5 radians per second squared acceleration times our 20 seconds. So that gives us 50 radians per second. So that's the speed at 20 seconds, and also for the continuing time of the latter 20 seconds. So just to finish up the question, we now can complete here our delta theta total. Omega I is 0, so don't need to include that term. So I just have 1/2 2.5 radians per second squared, so that's then a half alpha times the first 20 seconds, all to be squared, plus this 50 radians per second, the speed it has for the remaining 20 or the last 20 seconds, times the 20 seconds. And I believe this should give you 1500 radians. But the choices are in revolutions. So we want to convert that number to revolutions. So delta theta in revs, is 1500 radians divided by 2 pi radians per revolution. And we divide the 1500 by 2 pi and end up with 240 revolutions. So choice A being the correct answer for this question.